Welcome friends to the next lecture, that is the third lecture on this topic, that is Introduction to Spectroscopy. In this lecture we will start the complete list of different spectroscopic method. Then this is the various different spectroscopic method we can discover for the analysis of the structure or information, getting information from the molecule. The very first is the astronomical spectroscopy. In this astronomical spectroscopy, energy from celestial objects is used to analyze their chemical composition, density, pressure, temperature, magnetic field, velocity, and other characteristics. In this spectroscopy, if you are to getting information regarding its structure, its size and shape, then this type, in this case, we can use by means of analyze their chemical composition, density, pressure, temperature, magnetic field, velocity, and other characteristics can be studied by use of astronomical spectroscopy. Second one is atomic absorption spectroscopy. In this spectroscopy, energy absorbed by the sample is used to assess its characteristics. The matter is absorbed some radiant energy, and this radiant energy absorbed by the molecule is characteristics of the uh, spectroscopy. Sometimes absorbed energy cause light to be released from the sample, which may be measured by a technique such as fluorescence spectroscopy. Sometimes this absorbed radiation by the matter is release some light energy we call as fluorescence, and this fluorescence can be used again in the fluorescence spectroscopy. Next one is attenuated total reflectance spectroscopy. This is the study of substances in thin film or on surface. The sample is penetrated by an energy beam one or more times, and the reflected energy is analyzed. This spectroscopy used to analyze coating and opaque liquids. Next one is electron paramagnetic spectroscopy. It is a microwave technique based on splitting electronic energy field in magnetic field. It is used to determine structure of sample containing unpaired electrons. If we have to find out the unpaired electron in an unknown sample, then this spectroscopy we can use. Then next one is electron spectroscopy. There are several types of electron spectroscopy, all associated with measuring levels changes in electronic energy level. If this spectroscopy we can use, then it will give the information regarding the changes in electronic level by an electron spectroscopy. Next one is Fourier transform spectroscopy. In short, we call it as FT spectroscopy. This is a family of spectroscopic technique in which the sample is irradiated by all relevant wavelengths obtained simultaneously for at a short period of time. Then absorption spectrum is obtained by applying a mathematical analysis to the resulting energy pattern. In this case, all range of wavelength, all relevant range of wavelength is irradiated simultaneously, often short period of time. Then this information is collected and analyzed by use of mathematical relation. Then we got the relevant information from the molecule. The next one is gamma ray spectroscopy. Gamma radiation is the energy source in this type of spectroscopy, which includes activation analysis and in mass bar spectroscopy. There is another one, spectroscopy mass bar. In this spectroscopy, the gamma ray radiations are used. The next one is infrared spectroscopy. In your syllabus, there is one part is infrared spectroscopy. In infrared spectroscopy, the infrared radiation is used, and these radiations produces vibrational energy in the molecule, so that The vibrational, because of the excited vibrational energy, it can produce changes in the molecule, and these changes in molecule produced by the information is collected and analyzed. We got the structure of the molecule by means of infrared spectroscopy. Although frequently used to identify material, infrared spectroscopy also may use to quantify the number of absorbing molecules. Laser spectroscopy, absorption spectroscopy, fluorescence spectroscopy, Raman spectroscopy, and surface enhanced Raman spectroscopy commonly used as laser light as energy source, so that it is called as laser spectroscopy. Laser spectroscopy provides information about the interaction of coherent light with matter. Laser spectroscopy generally has high resolution and sensitivity. The next one is mass spectroscopy. Rather than radiant energy, a high moving beam of electron is used to fragment the molecule. And this information about a sample is obtained by analyzing the dispersion of ion due to difference in mass to charge ratio. Again, this is this mass spectroscopy you have to study in your syllabus. In this mass spectroscopy, a molecule, a high moving electron beam is bombardment on this molecule, so that this molecule will fragment, will fragile, so that these fragments are analyzed separately according to mass to charge ratio and easily find out the molecular weight of the unknown molecule. Then multiplex or frequency modulated spectroscopy. In this type of spectroscopy, each optical wavelength that is recorded is encoded with an audio frequency containing the original wavelength information. A wavelength analyzer can then reconstruct the original spectrum. The next one is Raman spectroscopy. Raman scattering of light by molecule may be used to provide information on as Opper's chemical composition and molecular structure. The next one is X-ray spectroscopy. This is absorption spectroscopy, and X-ray electron of atoms which may be seen as X-ray electrons fell on fluorescence emission spectrum may be produced and created by the absorbed energy from a higher energy state into the vacancy. Then, advantages of spectroscopic method. What are the advantages of spectroscopic method? Then, the chemical method of analysis use including qualitative and quantitative analysis, functional group, structure determination, etc. But large, they requires restrictive, elaborative, time-consuming, and an amount of sample. The physical method used including finding melting point, boiling point, dipole moment, refractive index, molecular weight, and spectroscopic method. In the classical method containing physical method and chemical method. In chemical method, if we have to find out the information regarding the molecule, then it can be determined by reacting certain species with your desired unknown molecule. Then this using this technique, some of the information is loose, destructive of your molecule, requires huge time, so that this is the demerits. The physical method also includes, you can easily find out the boiling point or melting point, dipole moment or refractive index, but the spectroscopic method gives very short time with accuracy, gives exactly required information. The advantages of spectroscopic method, the very first is amount of sample required is very small. Only a milligram of sample you can easily find out the, if we only a milligram of sample can be used to determine the information we got from spectroscopic technique. Second, they are non-destructive. If you can use the milligram of sample, if after some times it can be reused. In many cases, sample is recovered to extent of 100%. These methods are extremely sensitive and very quick. The information obtained is accurate, extensive, highly reliable, and of permanent nature. Then, along with advantages, it can spectroscopic technique gives some disadvantages too. The very first is all of them need very costly instruments. If we have to use this technique, the requirement of instrument is necessary and it is highly costly. Second one, trained person are needed to analyze the results obtained. Without trained person, we cannot identify or analyze the sample. Hence, it is your chance to study hard the spectroscopy. You are obtain a good job in pharmaceutical industry to analyze the sample. Then, using physical method, chemical methods are complementary to each other, related to each other. It means a method useful in some contents may be unwanted in other cases. For example, chemical methods are useful for finding percentage composition of elements, detection of some functional group. Physical methods stands out detection of conjugation, stereochemical details. So chemists are jointly used with each other for merits and some demerits. Then the last point of this topic is energy type and energy level of atoms and molecules. So very first, energy in molecule comes in six forms. That is chemical energy, electrical energy, radiant energy, mechanical energy, nuclear energy, and thermal energy. All these six forms of energy are related and interconvertible. Spectroscopic makes use of mainly radiant energy. However, other form of energy can also be used sometimes. Electrons, either in atoms or molecules, are distributed in various energy levels. They are respectively termed as atomic and molecular energy level. Preferentially, electrons reside in the lowest energy level called as ground state, and electron can be promoted to higher energy level to attain excited state. But this requires input of energy into the system. If electromagnetic radiation is used as energy source, it gives an absorption spectrum. But when an electron falls from higher to lower energy level, it gives rise to emission spectroscopy. Means if your molecule is at ground level energy level, if it absorbs some energy, it will go to the excited state. It will go to the excited state. And excited state means it excites the molecule, means this your matter or your molecule absorbs some energy. In this case, we call it as absorption spectroscopy. After some times, the excited molecule come into the ground state. So that the ground, after the molecule is come into the ground state, it loses or it emits the energy. This energy we call as emission spectrum. As per the quantum mechanics, only the exact amount of energy equivalent to the difference in energy level will be absorbed or emitted. This is termed one quantum of energy for single transition, and the absolute magnitude of each quantum will differ according to the difference in energy level. Means here is the energy level E1 and here is the energy level E2. And this energy level, E1 is a lower energy level, E2 is the higher energy level. According to the quantum mechanics, only one quantum of energy for single transition, for single transition, and the absolute magnitude of each quantum will differ according to difference in energy level. If it is lower energy level, then the energy required for excitation is lower. If it higher energy difference, then energy required for excitation is higher. But the combination of atoms into molecules create unique types of energy states, giving unique transition spectra between these states. So the molecular spectra are complicated. If you can see here, the molecular energy level, Here, E term symbol is used for electronic level. Electronic level E0, E1, E0, E1. That is ground state electronic level, and here excited state electronic level. Between this electronic level, electronic state, there is a vibrational state also V0, V1. That is ground state, vibrational level, excited state, vibrational level, and between these vibrational, there is an one rotational energy, that is R1, R2, R3 are the rotational energy levels. Then molecular spectra can be obtained due to electron spin state, that is electron paramagnetic resonance, molecular rotation, molecular vibration, and electronic states. The transition energy order varies as the ionization energy is greater than electronic electronic energy is lower than vibrational, and vibrational energy is lower than rotational energy, which means one of these transition occurs depends upon the value of transition energy, that is delta E. Then it is found that absorbing species and wavelength or frequency of the radiation, it can be noticed that each electronic level consists of number of vibrational level, that is V0, V1, V2, etc. Further, each vibrational level consists of number of rotational level, that is R1, R2, R3, etc. So it is obvious that whenever electronic excitation occurs, it is accompanied with vibrational and rotational excitation also. If some lower energy level absorbs energy, then there is an electronic excitation occurs. Along with electronic excitation, it can also excites vibrational as well as rotational. Similarly, sometimes vibrational excitation is observed, then along with vibrational excitation, rotational excitation also observed. And sometimes rotational excitation is observed, then do not observe excitation of vibrational and electronic excitation, because rotational energy is lower in energy level than vibrational, then electronic, and then ionization. Here is your our topic is completed. There is some problems. Many times it is cannot ask for examination, but it is your for your practice. The very first problem is calculate the wave number and frequency of radiation having the wavelength of 5 micrometer. Here we have to convert micrometer into the centimeter. The very first, 1 micrometer is equal to 1000 nanometer, that is 10,000 angstrom unit, and 10,000 angstrom unit is equal to 1 into 10 to the minus 4 centimeter. Means 5 micrometer is equal to 5 into 10 to the minus 4 centimeter. Then we know that wavelength in terms of wave number, that is mu, is given by mu is equal to 1 upon lambda, that is mu bar. Then the value of lambda is equal to 5 into 10 to the minus 4 centimeter. Solving these, 1 divided by 5 into 10 to the minus 4, then we got 2000 centimeter inverse. That is the value of frequency, wave number. And wave number is given by mu is equal to c upon lambda, where c is the velocity of light. In terms of centimeter, we got 3 into 10 to 10 divided by 5 into 10 to minus 4 centimeter. Solving these, we got 6 into 10 to 14 hertz. Frequency in terms of unit is hertz. This is the problem first. Second one is Vivid Bharati station broadcast on frequency 1368 kilohertz. Calculate wavelength of the electromagnetic radiation emitted by transmitter. To what part of the spectrum does it belong? Here we have to find out the wavelength, and wavelength is denoted by symbol lambda, and lambda is given by lambda is equal to c, velocity divided by frequency. The velocity is given 3 into 10 to minus 8 meter per second, and mu, that is frequency, is given in kilohertz, that is 1368 kilohertz. In this case, we have to convert kilohertz into second by multiplying 10 raised to 3. After solving this, we got wavelength is given by 219.3 meter. Next one problem is calculate the energy of photon of the radiation having wavelength of 450 nanometer. And this can be, we have to calculate energy of photon, and energy of photon is given by Planck's equation. E is equal to h into mu. Mu is given by frequency is given by c divided by lambda, that is velocity of light divided by wavelength. Substituting the values of h, that is 6 points, that is Planck's constant, 6.623 into 10 to the minus 34 joule per second. C is the velocity of light, 3 into 10 to 8 meter per second, divided by wavelength is 450 into 10 to minus 9 meter. After this solving, we got the answer is that 4.417 into 10 to minus 19 joule. Next one, find the velocity of radiation having 720 nanometer wavelength and photons of energy 2.76 into 10 to minus 19 joule. Then again we have know that Planck's equation is equal to h mu. E is equal to h mu is given by c upon lambda. We have to find out the light velocity of light. So that c is equal to E multiplied by lambda divided by h. After substituting the values of E, that is 2.76 into 10 to the minus 19 joule. Wavelength is given by 720 into 10 to the minus 9 meter divided by Planck's constant. After solving this, we got 3 into 10 to the minus 8 meter per second. Here our completed topic first from your semester 5, that this is the introductory topic. Thank you very much.